Hello, ladies and gentlemen, and welcome to our today's event. And our today's event is dedicated to building highly available HyperV cluster using free Microsoft HyperV server. And this is the practice part of our webinar series, brought to you by Alexander Karavanov, Five9 Virtualization Security Engineer, and me, Max Kolomeitsev, StarWind Virtual SAN Product Manager. So let's move on to our today's agenda. Right. So first of all, we'll do a quick recap of our previous event and go through some key points of the theoretical part of the webinar. Then we'll talk about fulfilling our cluster prerequisites and things we need to do before we actually start configuring the cluster. Then we'll do a live demonstration of creating highly available storage for the free HyperV server. That is the part guided by me, and then I'll pass it over to Alex, and Alex will show you how to effectively manage the HyperV cluster and HyperV in general. At the end, we'll have a quick conclusion of our practical part, and of course the questions and answers session will fulfill your curiosity on the things we'll be showing today. Right, and with that, I'm not sure if everyone made it to the previous event or you decided to drop the death by PowerPoint and came to the practical webinar only. So I'd like to give a quick overview of our companies. So StarWind is a storage-centric company. Our primary product is StarWind Virtual SAN, storage virtualization platform, and this software allows to turn local storage of any server into a highly available SAN storage. We're headquartered out of Boston, Massachusetts, and we've got more than 250,000 paying and playing customers worldwide. And with that, I'm finished with my introduction, and I would like to pass the word over to Alex to introduce Five9.
Thank you, Max. Yeah, Five9 Software is a solutions provider for management and security applications for Windows Server and Microsoft Hyper-V environments. So our products are built exclusively for Microsoft Hyper-V ecosystem and include management, security, that it actually includes agentless antivirus and multi-tenant security with extension to Windows Asia Pack now, and is a conversion from VMware to Hyper-V. We are headquartered in Boston, Massachusetts, moving to Chicago though now, with offices in New Jersey and Europe, and we have more than 25,000 clients worldwide, with thousands of Hyper-V hosts managed and 100,000 of virtual machines protected with our security solution. So let's have a small recap, Max, probably about our last time webinar, right? So remember, we were actually covering the topic of getting the most of free Microsoft Hyper-V server, and last time we mentioned that out of the box you actually get the need to have at least 2 Hyper-V servers for Hyper-V cluster, and that is okay, probably right, but you also need potentially at least 2 more servers to create shared storage or a dedicated expensive SAN appliance to do that. Also, you were stuck with time-consuming management operations with pure PowerShell, and overall it did the job, but it wasn't very efficient. And our last time we discussed how to actually make that efficient and to make everyone happy, right, Max?
Correct. So indeed, vanilla free Hyper-V server is not that sweet to manage, and it requires a lot of additional tools to get everything up and running and configure it properly. And in our case, we added some new flavors to the game. We added Five9 and StarWind, and here Five9 covers the part of effectively managing the Hyper-V infrastructure and the actual failover Failover Cluster. And StarWind, make sure that you don't use too much servers. You just need 2 servers for both HyperV cluster and storage, and you'd never need proprietary dedicated shared storage anymore. StarWind takes care of the shared storage component from here. Right, and you don't need a PowerShell as well. So I mean, we lessen both management and storage headache in this configuration, but I'm not sure. Maybe can we actually minimize the PowerShell level or command line management level to 0? Alex, what can you tell me about that?
So PowerShell is still actually a very, very good way to automate, tasks, and obviously it is a great fit for huge environments. But if you run your own infrastructure using PowerShell, maybe a bit time consuming and requires quite a bit of a learning curve. So with 5.9 we cover all of your needs. Some commands still may be done via PowerShell, but and we mentioned them here, but we try to avoid that to make sure that you really save your time. So if you get your 2 new boxes with servers inside, right, so you obviously need to think what's next. And first thing you need to do, right, Max, probably you agree with me, is that you need to unpack. Yeah, obviously you can't really work with boxes, you need to use servers in. So you unpack and you wire that, and you set it up, all of that within your infrastructure. So the next step, you install your free Microsoft HyperV server on each of the servers. That is important. So you do the installation manually for each host. Microsoft HyperV server is a very low footprint, and it is free, so that's great by itself, but it also allows you to really save your resources and allows you to make sure that your system is more secure because it needs less updates. It doesn't have any extra components other than HyperV role and a few features, so that is actually very efficient, free, and secure. So the next step would be to install Failover Manager, and you can install it on top of your core Hyper-V host, so it works directly on core Hyper-V servers, and I'm going to show that to you today. So, and you use it to create identical virtual switches for your future clusters. So each Hyper-V host should have the same set of virtual switches. If you have your domain controllers within the infrastructure, you're all good starting from this moment. If you don't, and these 2 boxes are the only ones within your system right now, so you obviously need to create a domain controller, or in our case, as we are creating a high available cluster, we'll need 2 domain controller virtual machines, 1 per host for redundancy. So this requirement comes from Microsoft clustering needs. So to create a Microsoft Hyper-V cluster, you need to have domain within your system, and so Hyper-V hosts have to be joined to your domain. So this is where we are creating that. Then you join your Hyper-V host to a domain, and by the way, below you can see a small hint that actually shows you a command that allows you to do that. So that is very fast. And on the next step, you configure and provision shared storage with StarWind Virtual SNAP. And this is something that Max is going to demonstrate to us live today, right, Max?
Indeed, indeed. That's the cornerstone of the clustered environment, and we'll go through that as well. Right. And next, once we have configured everything on the storage side, we go through some more PowerShell, just a little bit, and we install the failover clustering feature on each Hyper-V host. We install the multi-pathing feature to operate with storage properly, and you see we also have the PowerShell script here, so we don't need to ask you to Google them. We are trying to provide as much information on the configuration as possible. So anyone who wants to configure this solution will be able to download 5.9, StarWind, and free Hyper-V server, get this presentation downloaded with our follow-up email, and give it a try himself. It's really easy, and our marketing analysts who are not really IT proficient managed to accomplish that within 1 hour, which is really great. Now, I digress. Eighth step is to validate our HyperV configuration and use one of our domain controller virtual machines as the controller for our cluster. And of course, after that, we create a new cluster and initialize the disks and add them to the cluster shared volumes list. The command for that is pending. I'd have to double check one thing with our PowerShell guru, and after that, in the follow-up, I'll make sure that we add these commands in the email. Okay, so here is the configuration overview of our today's demo stand. We've got two servers running HyperV server, running StarWind, and running Five9. And we have connected them with standard Ethernet cables. And to use StarWind, we mirror the local storage of each server and then present it back to the same servers as single shared storage resource, which we then use to store our virtual machines. And with that, let me quick pause our screen share and prepare the demonstration for our StarWind part.
While you're doing this, Max, yeah, so just please take your time. We have a question from Shankar regarding the domain controller need. So he's asking if the domain controller is mandatory. So right now it is a must to have it, to have a high-level HyperV cluster. There are some ways to actually create detached clusters, but they really lose quite a few very important functionalities, and doing that is as efficient as probably cutting out a lag to lose your page. So that is not something you want to do. So you really need a cluster to set up a HyperV cluster. You have to have domain control to set up HyperV cluster.
Indeed, indeed. Right, so let me know if you see the screen, Alex, and I can start the presentation here.
Yeah, you can see your screen now, Max. Please move forward.
Okay, excellent. Yeah, and one more thing I would add about the domain detached clusters. So it's still a bit contradictory because you can configure it, but one of the requirements and prerequisites for the domain detached cluster is to add both servers to the domain. I'm not sure what Microsoft meant by with saying that, but that doesn't seem like the most accurate way to create a domain detached cluster. Right, so we have our two servers today, HVN1 and HVN3. You can see them inside the StarWind Management Console here. This is the place where we are creating the storage from, and we'll then RDP into our servers to check for additional parameters you may need to bring the storage online. Right. So right now, we have joined our servers into the StarWind cluster. This is just a virtual entity which simplifies creating storage. So this is not the actual failover cluster. The actual failover cluster you'll see a little bit later. Now, we go to servers. There are same servers here, and there are also some devices I have pre-created for the sake of this event, because otherwise we won't be able to narrate and configure the cluster within 1 hour. It would be a really boring event, so we try to keep it a little faster and try to provide a more interesting information rather than ask you to wait while we validate the cluster and then wait while we connect all the storage and stuff like that. So here's a quick way to add storage. Here, we right-click on the cluster, press Create Clustered Storage, tell the storage name, let's say CSV2, and let's say 10 gigabytes. We'll provision 10 gigabytes from our local storage to a highly available storage pool. We'll say it's stick provisioned for now. And we have our two servers on the left, and we just add them to the right part to use their local storage. We press next. It goes through a lot of different procedures here on the screen, and then tells us a summary. Okay, guys, we are ready. We have created the shared storage on both servers. Okay, the cluster shared storage is created. Right now it is synchronizing, so it has to align and do a full initialization. And while it does that, we have some time for quick questions you might have for our today's event. Let's see.
So guys, so if you have any questions, we'll run a dedicated question and answer session in the end, but we're also able to answer your questions right now while the process is going on. So if you have something else you want to clarify, please don't hesitate to put it into a question box. While it's doing this, Max, actually, I probably have a question. So can you probably explain a little bit the process that is happening right now? So what do you guys do with shared storage for these HyperV hosts now?
Okay, so right now we have allocated 10 gigabytes from each host's local storage. Then we granted exclusive access to StarWind to these 10 gigabytes, and we are now making sure that there is no data in this 10 gigabyte chunk. We are aligning them and then presenting them as a new physical device to the same nodes where we are creating this. So effectively, you have two hard drives. On both hard drives, you have 10 gigabytes of them allocated, and then all of a sudden in the device manager you see a new 10 gigabyte hard drive, and when you write to that hard drive, you technically are writing to both nodes at the same time. So in this case, should one node fail, second node will keep up, and same will happen to the virtual machines running on this storage. So should anything fail in this configuration, we are redundant and we can continue working even, let's say, if half of the configuration is down.
So,
okay, so we're nearly synchronized.
This is a real high availability, Max. This is a real high availability. This is what we need for our cluster.
Indeed. Indeed. And one more thing is that this high availability is not dictated by StarWind. It is dictated by initiator side, so by HyperV itself. So it's HyperV who decides when it needs to switch from a failed node to a healthy node. So we do not need to configure some additional parameters for HyperV or for vSphere or for any other hypervisor working with StarWind. It's always the hypervisor who decides where to put that comma and continue working with the other StarWind server, so we never get into misconfigurations on that level. That is really important stuff when configuring storage. Okay, so we're now nearly finished. Oh, we're actually synchronized now. And here's our CSV2 device. Right, before, when you wanted to connect the shared storage to the core operating system like free HyperV server, you had to remote into it and do some HyperV initiator commands. Luckily, HyperV initiator comes as a GUI even if the operating system has no GUI. So let me show you what it was like before and then show you how we simplified that. Right, so we have a remote desktop connection to one of our servers, and we have the HyperV initiator. So here is how it looks like. Even in a core version, we have our devices here. We had to go refresh, see the actual devices list, and then press connect on one server, press connect on the other server, and stuff like that. This is not really a good way to do that. I mean, it works, but it's a little lengthy procedure, especially if you have multiple targets. So what we decided to do, we decided to get this functionality right in the StarWind Management Console. So right now you see this fancy button, Connect Storage on the servers. And once we click that button, we connect the storage to our initiator servers automatically. So right now it's doing some loading stuff. And see, there we go. We are on the second tab. Here are the servers which are connected here. And if we go back to our SCSI initiator on the client machine, if we refresh, we'll see the storage is now connected. So this is the automation we did for the device connection. And we're also working on another automation. And let me show you for now how it looks if you do that via command line. So let's see. Next thing we need to do is go to disk part. Right? Yeah. Okay.
Now, Max, while you're doing this, I can see quite a few questions in our list right now. So, guys, please be a bit patient on that. We'll answer all of your questions in the very end of our webinar, so 100%. So just stay tuned and we'll answer all of them.
Sure. I mean, I can try multitasking at this point. I'm not sure. This will result in a quick answer, but that's something we can try to do. Right, so we have first listed our drives here, then we selected the drive we just added. You see the new device here, the 10 gigabyte device, which we just created from nowhere. Right, and let's see. Right now, at this point, disk part can also help you. So if you select like online disk, we have online the drive, and let's see if we online it successfully. There's disk. Yeah, the drive is now online. Excellent. And now once we selected the disk, we can create a partition on it. Right?
Sure.
Okay.
So while it's loading, Max, probably there is a time for one question. So is this console full enabled in a starter pack? So I assume Jandos is asking about the StarWind console in this case.
Not sure I got the question correctly. I mean, if this console works on the core version as well, or is it just a GUI-enabled version?
I think right? I think it is about the functionality inside. I think all the functions that you have within your current console. So is it available, as I said, in a starter pack? I know it's hard to multitask sometimes.
Yeah. Let's see. I'll just open the questions and answers box. Okay. Oh, okay. Core version of your product. Yeah. So technically, we do have a core version of StarWind. You create storage with StarWind using PowerShell commandlets. We have our StarWind X PowerShell object, which can help with that. And that would be the best way to do that.
Okay, so let's probably move forward with our partitions here. So are they on the way?
Yeah, they're nearly done.
So we may have some time for one more question, right?
Yeah, sure. Why not?
So
okay.
So we have a question from Marker in this case. So should we have the same disk size on both servers?
That is recommended, but it is not necessary. So I mean, at this point, you're only limited with the storage you can make HA. So you're not actually limited with how different your drives are. So you only need to have, let's say, 1 terabyte of storage. So that doesn't necessarily put you in a situation where you need to have 1 terabyte of storage on each node. It can be a 5 terabyte volume on one side. It can be a 1.5 terabyte volume on the other. Just the idea is that the common denominator of this storage will become the HA portion of it, right? And actually the only requirement for now, I would say, is that the storage performance is identical. Storage performance should be within 5, let's say 5 megs a second or 100 IOPS between the servers. Otherwise, one server will inevitably become a bottleneck in the configuration, because we are doing this synchronous mirroring, and each write is only confirmed when it is written to both nodes. And if one node is extremely slow and doesn't keep up on the load, there is no way we can do a fast configuration. Right. So at this point, I have finished our preparations. Let me just double check I have everything connected on both servers. Right, so okay, looks good. Our devices are now connected to both nodes. And let's see. And now initialized. Okay. Right. So at this point, the devices shown here should be visible inside our failover cluster, and we can start provisioning our virtual machines on them. And one more thing, the main idea of this configuration is that once we provision those virtual machines, we should be able to fail one of the servers without any consequences for the virtual machines running inside the cluster. So I mean, if that's the node, if we're restarting the node which holds these virtual machines, then they will restart on the partner node. But if we restart the node which doesn't have the virtual machines running, let's say it's an asymmetric configuration where one node is running all the VMs and second node is hot standby. In this case, the cluster will never notice that storage has failed or anything happened to the backend systems. Everything is redundant and it just seamlessly fails over to the partner path and continues running from there. Right. So with that, I'd like to pass the demonstration part to Alex, and Alex will show you how we actually manage this HyperV cluster using 5.9 HyperV Manager. So while Alex
thank you, Max. Yeah, thank you.
Starting to present the screen.
Yeah. I'm currently switching to that mode, so
okay.
It should appear on your screens in just a few seconds. Please let me know whether you can see that. Okay, great, fantastic. So thank you again, Max, for telling us and showing us how to actually create the shared storage without extra hardware between your Hyper-V hosts. So, and once you've done this for your Hyper-V host, you create your cluster shared volumes, and something you need to check before you actually manage your cluster. You need to check if you can see your cluster shared volumes, and you can see that they are assigned correctly, and there is space available on this cluster shared volumes. So once you've added cluster within File Manager of Hyper-V, and you can see it works on server core. So once again, if we have a 2-service configuration, and this is a high available cluster consisting of 3 Hyper-V servers only, so you can have File Manager installed on each of these nodes, on one node, wherever you feel more comfortable to manage that, and it can run directly on a GUI-less environment. So you can see that right here. So you've added your cluster into File Manager console. So the first thing you check the space available and if cluster shared volumes are attached to your cluster correctly. Then you can go back to your cluster itself and see the Hyper-V Manager tab. So this is where you can actually perform operations that are so great for your cluster. So you can actually pause cluster nodes with or without draining roles. Afterwards, you can just use resume operation, and these are so important, so convenient whenever you have a cluster setup. Every single virtual machine can be made high available with the right-click menu. So you just function that does it, just add to cluster. As simple as it is. So you can make a virtual machine high available, or you can remove high availability of this virtual machine. So this is done with just one single click. You don't need to go through any wizards. So that's very convenient. As of another advantage that you get with the cluster, you can actually leverage the live migration. And live migration is surely a great thing that allows you to move virtual machines between Hyper-V hosts in few seconds, actually, by copying over memory from one host to another, and the storage is the same. Actually, a Hyper-V host runs your virtual machine on another server in just a few seconds very seamlessly. Migrations available, so these are pretty standard. So you can choose best possible node, that actually is the node with the most available memory, or you can put it on a host that you want this virtual machine to be on. So that is where you can figure that, and these cluster operations, of course, are very important, and these are the ones that you can do and perform within File Manager for Hyper-V. When you have your cluster, and especially on an initial stage, you really want to create multiple virtual machines to put your business processes on these virtual machines and to make sure that everything you need to have as a service is running there. So usually to do that, you have to go install each virtual machine individually, but with File Manager, you can leverage clone functionality, and once you have a virtual machine with Windows Server 2012 R2, for example, and you sysprep that, you can use it as a golden image and create as many clones as you need to speed up your initial configuration and to speed up the creation of all the services within your Hyper-V infrastructure. So you can create as many clones as you need, and this really results in a huge time saving. This operation may be time-consuming sometimes, right? Once you've started, so all of these operations can be put into background. So when you start it, so it allows you to put that operation into background, and all background operations are logged within a task log that actually allows you to keep working with your Hyper-V management instead of staring at the screen and wait until operation finishes. So it allows you to monitor all the operations happening and see the status of that, see if it's accomplished successfully or if there's some issues there. So this is where you can check it out, and this is actually very convenient from the viewpoint, and is also very convenient from the performance standpoint, so because you can keep working while these operations are happening. So this is available within a task log, and that's very conveniently hidden right here. Another thing that is so important to understand when you have your cluster set up is the way to actually get notified if there are some unexpected events happening. So once you have set up your HyperV cluster, you create your virtual machines, and for example, you're a normal admin there. Obviously, you expect that nothing is going to happen unless you come and you do that. So therefore, within File Manager, you can set up notifications in case someone else does these operations, not you, or just for your awareness. When you want to be aware about all the operations that got performed in your HyperV cluster. This is where you can do that. So you can select these checkboxes and get notified if someone creates a new virtual machine, removes, starts, or restarts it. Turning off virtual machine is also pretty significant operation, right? You need to be aware about that. If you store sensitive data, or you want to make sure none of the virtual machines, non-authorized virtual machines get imported, so this is where you can specify import and export VM notifications. If you use replication and you keep your data secure between multiple sites this way, so it's very important to be notified if replication fails, right? So you can see replication health when you open up Management Console. Of course, that gives you an idea about that, but the most important moment of time when you really want to take some action is the time when replication fails, and if this happens. So this is where you can also get notified about that. So this is also very significant and very important option available within File Manager for HyperV. And in version 6, we've implemented a very important functionality to maintain highest resource usage, or at least optimal resource usage within your infrastructure. So this is called Optimizer within File Manager, and obviously that's dynamic optimization of your virtual machines load. And in case some of your virtual machines need more resources from your system, this is where you can be confident and move it around, or move other virtual machines around to other hosts that are not as loaded automatically. So you don't have to keep your eye on that, and you don't have to keep your eye on resource utilization by each virtual machine, but you can leverage the automation process by selecting virtual machines in groups and making sure that they migrate automatically without your further interruption. So this is available by automatic dynamic optimization, available within File Manager for HyperV version 6. So this is a new release version, and you're very lucky because you are first to see this option and the functionality in action. So you see, File Manager analyzes the load and analyzes CPU memory and disk time usage, and it allows you to perform dynamic optimization of your virtual machine's load among HyperV hosts. There are multiple scenario support. Best way to leverage that is, of course, on HyperV cluster. This is our today's topic, but it also supports shared storage. And if you have shared storage, you have virtual machines there, or if you want to optimize the load between several hosts that don't have shared storage, that is not recommended, but it's also available within dynamic optimization here. So once again, best way is to use it within the cluster with shared storage on your system. So this is it about File Manager for HyperV version 6 from me for now. I think these functionalities are the most important whenever you have set up a cluster on free Microsoft Hyper-V server. File Manager, of course, includes many more features, including the Agentless Antivirus plugin and separate cloud monitor with a web interface that allows you to monitor performance. But these are the core ones, and these are the ones that are actually going to help you within your daily Hyper-V cluster management. So right now, let me switch back to a presentation, and it'll take a few seconds. Meanwhile, please feel free to ask your questions in the question box. Q&A time is coming very soon. So if you have any, please feel free to put them in right there. So, Max, can you see a slide right now?
Yeah.
Okay.
Yeah, we've got our conclusion here.
Right. Yeah. So it's been a while, right, since we started. So in a conclusion, we can say, right, and Max, you agree with me on that. Now, so we actually know that with help of StarWind and Five9, you could actually save tremendous amount of funds for your system. So at least 7,000 of US dollars saving on getting the physical sign on all and extra OS licenses that you would need to get if you don't add StarWind and Five9 there. So we strongly believe that this is the best and optimal configuration that you can leverage, and we are very excited that we can share that with you right now. So let's probably move on to our Q&A section. Please feel free to put your questions in the question box and we'll start answering them right now. Meanwhile, I'll keep our contact slide on the screen so you can find download links for StarWind Virtual SAN and File Manager for HyperV. Same from my side, we in Five9 now run an exclusive discount for you guys, so that is available till the end of this year. It is 25% discount for File Manager for Hyper-V till December 31st.
Right, and I would add that from the StarWind side, we just launched a new rule for our sales. First of all, we have a net 90, so if you sign a purchase order with StarWind, you have 90 days to pay for the product, so you can actually get it in 2014, but pay for the product in 2015. And of course, we offer a 30-day money-back guarantee, no questions asked.
Absolutely. So we have quite a few questions, Max, in our question and answers box. So guys, be confident if it takes really long and your question is not yet answered, be confident we'll answer every single question after the webinar as well, when we will be doing the mailing for you. So let's probably start with one of the questions that we have for quite a while. So we have a question from Steve, and he's asking, do the hard drives need to be the same type? Could one server have 10K drives and the other ones 15K drives for the clustered storage? I would assume this is a question to you, Max.
Yeah, I think so. Right. So the drives can be different, but the main idea is to have approximately the same performance. Or if you realize that your configuration will eventually be bottlenecked by 10K drive performance, then this is something you can do. But the best practice is to keep everything at one level. So if you have 15K SAS RAID 10 on one server, it's a best practice to keep 15K SAS RAID 10 on the second server as well.
Okay. Thank you, Max. Thank you. We also have a question from Pete. He's saying that he ended the webinar a bit later, and if you're going to have an archive of that. So yeah, Pete, we'll actually send slides and video recording for you after the webinar, so probably in a day or two. So stay tuned. You'll receive the link for that. Okay. So Max, would you like to pick up one of the questions?
Yeah, sure. Let's see. What's the time span of the synchronization? So that's a question from Shankar, and that's a question I may need some clarification on. So Shankar, if you could please elaborate on the question, I'd be really grateful. Then a question from James here. I missed a basic premise. Is StarWind cloud-based or a device on site? It's not a device, it's just a software, so it can be installed on-premise or in virtualized environments as well. So it's not for a public cloud yet, but you can have it on-premise and replicate it to the cloud. Then question from Robin, actually two questions from Robin. What connection do you use CSD sync? We use 1 gigabit cables in our case. In case of a production environment, it's usually either a team of multiple 1 gigabit cables, or it's a 10 gigabit connection. That's the most widespread configuration for SMBs. If we look a little higher, StarWind is used a lot with Mellanox 40 gigabit Ethernet gear right now. That would be.
Okay. Yeah, I think.
Okay.
Yeah, it really sounds clear now. So Jandas is asking actually if we have a web version of console for easy access, and if there are ports for optimizer. I assume this is a question about Finance Manager. So as of a web version, currently this is a console version only, but we will be announcing web version Finance Manager next year, so you guys really learn some insights on this webinar. So indeed that is very desired functionality for Hyper-V management, and this is what we are going to announce next year. As of reports for optimizer, you could see the graph that actually allows you to see all of that, and obviously task log shows you all operations happening with your virtual machines. As of a performance, there is a web-based performance monitoring solution that actually goes with the full version of Finance Manager for free. It's called Finance HyperV Cloud Monitor, and it allows you to monitor all your system performance, including virtual machines, utilization, resource utilization, hard disks, just hosts themselves, even a whole data center with alerts. So we believe that it really helps you to get all required reports and notifications in case performance is overused. Okay.
Okay, and there is a question we have from Jandas. Do I need 2 licenses for Hyper-V host to build cluster? From the StarWind perspective, you only need 1 license. From the Microsoft perspective, you don't really need a license since this is a free product. And I'm not sure about Five9. Alex, would you hook me up, please?
Sorry, Max, I just got on a question right here. If you clarify that for me, it would be really helpful.
Sure. So the question is, do I need 2 licenses for 2 Hyper-V hosts to build cluster? So from the Five9 standpoint.
Yeah, from our standpoint, right, so Finance Manager for Hyper-V is licensed per Hyper-V host. So yeah, you get 2 licenses to build 2 Hyper-V host clusters. So if you need 3, so obviously that's 3. And you can use as many management consoles as you need. So you can use Finance Manager for remote management, for local management, whatever you find more useful and more convenient for you, this is the way to go. Hopefully we can answer these questions.
Yeah, and there is one more question. How many times in a certain time will StarWind sync? So the answer would be StarWind synchronizes the data all the time. So every written block to the disk is synchronized. So it's actually only considered written as soon as it's synchronized. Now, then, let's see.
Okay.
There was one more question, but I lost it in the questions list. Okay, there it is. Sebastiana asks us, does the HA disk performance differs from the non-HA disk performance? Yeah, there is a slight difference since the HA disk needs to synchronize the writes between the hosts it mirrors between. And that's why the performance may be limited to the throughput of the synchronization links between the servers.
Okay, so it looks like we are very close to a full hour. So let's probably run our questions and answers section for a few more minutes, and then we'll probably have to answer some questions via the email.
Okay, so just got a few questions here. So question from OutCydia. Is it better to use Cachecade or similar SSD acceleration on the SAS RAID controller, or use SSD in StarWind for L2 cache? I would say that using SSD in StarWind for L2 cache is a better idea, since we will apply our own mechanism of tiering the data between hot cache and cold cache, so it's RAM cache and SSD cache. And this way we can make sure that the hot virtual machine data stays in the L2 cache. If that is decided on the Cachecade level, we cannot guarantee that the data we need will be in there. And there is one more question from Claude on StarWind. What is the difference between thick and thin provisioning, and what is the best practice? It depends on the load. So thick provision drives are standard drives with classic data on this distribution model, and thin provision drives incorporate our new VM-centric file system, which is LSFS, or log-structured file system. It's a system which eliminates random writes by combining huge amount of small writes into big sequential writes. So it allows you to get the most of your spindled arrays, and it also is really flash friendly. So not only it log structures the data, but it also deduplicates the data inline. So at the end, a lot of the writes which happen to the certain one are not written to the disk, but deduplicated first. So they only stay in RAM. So effectively, that topic deserves a much more sophisticated explanation. We'll be having a webinar later this month on this topic, so I would really recommend joining that one to get the better understanding on how log-structured file system works. As an easy explanation, I would just say that if you have a lot of reads in your environment, I would stick with thick provisioning. But if your environment is really write intensive and you have tremendous amounts of random writes, then thin provisioning and LSFS are the best practices.
Okay, so I would like to answer one more question that is actually very important regarding the cluster configuration. So we have Robin asking if our HyperV hosts have exactly the same hardware regarding the CPU RAM. So Robin, you know that in 2008, HyperV, you actually had to have exactly the same hardware for every single piece of that. So to create a cluster. In 2012 and 2012 R2, there is no such a requirement anymore, so your system will actually run, but it is still very, very recommended because of our configuration processes. As of the CPUs have to be the same model actually to give you live migration capabilities. So if these are different, you will lose that, or you'll have to use legacy mode that actually eats up your performance. So if you have an ability to actually get the same equipment to create a HyperV cluster, please do so. If you don't, just make sure that they're as close as possible and they're using the same CPU model. So this is what I would say about that. Okay, so it looks like we are close to an hour right now, and I think it's time to wrap up and close our session. I think we'll keep up the questions box running for another few more minutes, so you can type your questions in, and we'll answer all the remaining questions in our follow-up email after the webinar. So thank you everyone for attending our webinar today. Hope you enjoyed it, and you're ready to go and put your hands on creating your own HyperV cluster with help of StarWind Virtual SAN and File Manager for HyperV.
Bye-bye.
Goodbye.